simultaneous equations. In simultaneous equations, we have two equations for two variables. And normally like x and y, so we might have something like 2x plus 3y equals 5, and we might have x minus 2y equals negative 1. So we need two equations so that we can isolate the single solution to those two equations at once, for x and for y. So there are two methods that we deal with. We deal with the substitution method, or we deal with the elimination method. So in the substitution method, we substitute one variable into the other equation, and we solve the resulting equation. In elimination, we get rid of one of the variables by adding them together or subtracting the two equations together. Alright, let's look at the substitution method first. So the substitution method works best when we have something that says y equals something or x equals something. Now the question might not give it to us that way, we might have to rearrange it, but let's say we had 2x plus 3y equals 5, and we have x equals 2y minus 1. So we have two equations. We have equation 1 and we have equation 2. So you can see that we've got two equations, two variables. One of them tells me what x is. So what we're going to do is we're going to take this x and we're going to replace that x with it. Now I know that x equals 2y take away 1. So I am going to sub 2 in 1. And what happens when I do that? Well, this is 2x, so it's two lots of what x is. And x is y take away 1. And we add the rest of that equation. So this bit here is what x is. So I've replaced x in that equation with what x equals, and I'm left with an equation that only has one variable in it. There's only y left in any of this. So now I can get the single solution of what y will be. So to solve that, all we have to do is expand. So we get 4y minus 2 plus 3y equals 5. And collect like terms, we get 7y minus 2 equals 5. 7y equals 7. Y equals 1. Okay, now we're not finished. We know what y is, but we don't know what x is. So we've got an equation up there. X equals 2y minus 1. So sub 3 in 2. X equals 2 times whatever y is. Take away 1. And we get x equals 2 times 1 is 2, minus 1 is 1. So therefore, x equals 1 and y equals 1. Alright, now I'm just going to make them all 1, 1 because that's easy to make. Alright, sometimes it won't be that easy, but if you can find a variable by itself. Now it doesn't say x equals or y equals, but you can see this x here. This x here is by itself. Now I could make this say x equals. If I rearrange number 2, then I can make it say x equals, well, if I move that over there, it'll become minus 5y. And if I move the 6 over, it'll become plus. So we've got minus 5y plus 6. And now I do have x equals. So I can take this equation, equation number 3, and I can put that in equation number 1. So again, I'm going to replace x, this x here, with what x equals. So the question that I now have to solve is 3 lots of negative 5y plus 6 plus 4y take away 7 equals 0. And again, we're just left with a single equation with a single variable of y, and all I have to do is finish this off. So if I expand that, I get minus 15y plus 18 plus 4y take away 7 equals 0. And if you collect like terms, minus 15 plus 4 is negative 11y, and 18 take away 7 is 11. Take away 11 from both sides, and divide by minus 11, y is 1. And I take my y equals 1, and I put it back into an equation, and I put it back in number 3. Minus 5y plus 6. Minus 5y plus 6. Minus 5 plus 6 is 1. So again, we get, therefore, x equals 1, y equals 1. Now they're not all 1, 1. 1, 1 is just an easy equation for me to make up on the spot. That's how it works. Okay, the last type that you might get with this, you might get something like 4x minus 3y equals 1. And you might get 6x plus 12y equals 18. Now this question, there's no singular pronumeral. But if you look at number 2, we can see we've got a 6, a 12 and an 18. Now those 3 numbers are all divisible by 6. So I can take number 2 and divide it by 6, and that will give me x plus 2y equals 3. So I've effectively made that singular pronumeral happen just by dividing. So you can do that as well. And if the numbers are nice and neat, like if they all go into the same number, then that's probably your best bet. But I mean, if that was 13y instead of 12y, you couldn't divide it by 6. So then we do the same thing. We're going to rearrange number 3 so that we get our x by itself, and we're going to get x equals, well, we're going to move that 2y over the other side, which will make it opposite, so it's minus 2y plus 3. And I'm already up to equation 4. And we're going to take equation 4 and we're going to put that in equation 1. So it's 4 lots of what x is, minus 3y equals 1. Minus 3y equals 1. And again, same situation. We've just got one equation, one variable, solve it to get y. So minus 8y plus 12 minus 3y equals 1. And if we collect the like terms, we get minus 11y plus 12 equals 1, minus 11y equals minus 11, y equals 1. Use your y to get an x. Sub 5 in 4. x equals minus 2 lots of y plus 3, and again it equals 1. Therefore x equals 1, y equals 1. Okay, so for the elimination method, you're either adding the equations together or you're taking them away. Depends on the equation, depends on the question. So you take them away if they're the same. So if we've got, say, 2x and 2x lining up on top of each other, and if they're different signs, say we had minus 2x and 2x, we add them together. So 2x minus 2x is nothing, and minus 2x plus 2x is also nothing. So our goal is to end up eliminating one of the pronumerals, either eliminating the x's by adding them together or eliminating them by taking them away. It's all about eliminating. So you can try adding the questions together or taking them away and seeing what happens. If it doesn't eliminate them, then it's the other one. So you go and do the other one and just see. So an example, let's say we had 3x plus 4y equals 7, and 3x plus 2y equals 5. So there are our two equations. Now, elimination method happens best when we've got matchy-matchy. So you can see there, the 3x and the 3x are the same. So you can write a little plus or a minus next to it and just try the pluses. What happens if I add these two equations together? Well, I'm going to get 6x plus 6y equals 12. That's no good. I haven't eliminated anything, so it's not plus. So let's try minus. What's 3x take away 3x? Well, that's 0. That's a good start. 4y take away 2y is 2y, and 7 take away 5 is 2. Well, that's good. I've eliminated them. So what we did there, we did equation 1 take away equation 2. And I can solve this. The 0, I can ignore the 0, divide by 2, and I get y equals 1. Now these ones, to get your second pronumeral, are a little bit harder because you don't have a nice equation that says x is this. You have to take your 1 and put it in one of these equations. Put it in one of these equations, and then solve. So let's put 3 in 2. So 3x plus 2 lots of y equals 5. And 3x plus 2 equals 5. 3x equals 3. X equals 1. Alright, so a little bit more involved in finding the other pronumeral when you're doing elimination, because you don't have that nice neat x equals. Alright, the second version of that, 2x plus 3y equals 5, and 4x plus 5y equals 9. So this time we don't have anything that matches. So what we want to do is we want to find a way to match something. So if we look at the two equations, if I take away or add any of these together, I'm not going to match. The 3 and the 5 aren't going to cancel out, the 2 and the 4 aren't going to cancel out. But what I could do, I could make these two things match. If I took equation 1 and I multiplied it by 2, I would get 4x plus 6y equals 10. So now if I look at equation 2 and equation 3, I can see I've got a 4x and I've got a 4x. So now they match. So if I add them together, 4x plus 4x, that's 8x, so it's not plus. 4x take away 4x though is nothing. So 3 take away 2, and I'm doing that because I've got 6y here, it's bigger. So I'm just going to keep it positive. So 4x take away 4x is nothing. 6y take away 5y is 1y. And 10 take away 9 is 1. So y equals 1. That's number 4. And to figure out x, sub 4 in 2, so I can still see it. So 4x plus 5 1s equals 9. Finish solving it, find out what x is. 4x plus 5 equals 9. 4x equals 4. X equals 1. So that's all well and good, unless 3x plus 4y equals 7, and 5x minus 3y equals 2. So, in these questions, I can't turn 3 into 5 and vice versa. I can't turn 4 into 3 and vice versa. So this time, what you have to do, and it's a bit longer, you have to change both. So it doesn't matter which way you do it, but you have to make a match with x or with y. So I can't change 3 into 5, but what could I change them both into? 15. I can't change 3 into 4, but what could I change them both into? 12. Okay? So it doesn't matter which one you do, you'll get the same answer. I'm going to do the y's, I'm going to change them both into 12, just so we can do a plus minus one. So if I change them both into 12, I need to times number 1 by 3. And that will give me 9x plus 12y equals 21, which is my equation 3. And I need to do equation 2 times 4, which will give me 20x minus 12y equals 8. So now I can see there's a match. I can see the y's are matching. Now the plus minus one is probably the more tricky of the two, because a lot of people they just think it's a straight takeaway. But if you take away, if you did 12, take away minus 12, it turns into 24. So it's not a takeaway. This time it's plus. If you add 12 plus minus 12, you will get 0. So we're going to do equation 3 plus equation 4, and that will give me 29x plus 0 equals 29. So x equals 1. Same process, take your x equals 1, figure out what y is. It's going to be 1. It doesn't matter what equation you use, I'm just going to use that one I can see. Sub 5 in 4, 20 times 1, minus 12y equals 8, 20 minus 12y equals 8, minus 12y equals minus 12y equals 1.